All right. So what we covered yesterday was solving logarithmic and exponential equations with like bases. And if they didn't have like bases, we were able to rewrite it so that they did. Because if they do have like bases, the exponents must also be equal.
If you're in the building, please come to the office.
So for the ones that we'll look at today, the bases are not going to be the same. So here we have 2 to the x is equal to 7. 2 to the x is equal to 7. Well, here the bases are not the same. And there's no way that we can rewrite 7 so that it is 2 to an exponent. Now, we talked about this a little bit yesterday and on Monday when we brought it up the first time. That if I apply a log and the base and what's inside the log are the same, they will simplify out. So if we were to take log base 2 of 2 to the x, what would we actually have? X, because this would be, the log base 2 of 2 would simplify out and we would just be left with x. And what I do to one side, I have to do to the So over here, our log base 2 of 2 is going to simplify and leave us with just x. Or really, we can move the x out front using our power property of logarithms. And 2, log base 2 of 2 would simplify, leaving us with the fact that x is equal to log base 2 of 7. Now, at this point here, we can type this straight into a calculator. Because I can use the graphing calculator and go to math, then log base, and plug in log base 2 of 7 and get my answer. Now, if I don't have the graphing calculator, well, we can rewrite this using the change of base, which would be what? Log of over. So we can plug it in either form, and if we do, we get and the decimal continues on further out. It's a non-repeating, non-terminating decimal, most likely. But this is what we get. X is equal to 2.807. And that's it. We found the value of x, for which 2 to the x is equal to 7. Any questions on any of this here? We ready for the next one? Give myself a little more space. So this time we're solving 3 to the x equals 8. And again, like most of the ones we're going to encounter today, I cannot rewrite them so that their bases are the same. So what can I do? Yes, I'm going to apply log base 3 to both sides. Because our log base 3 of 3 to the x is just going to be x. And on the other side, we're going to have log base 3 of 8. Eight, 9, 2. And that's all we have to do for this here. Any questions on any of this here so far? Okay, so we have 7 to the 9x equals 15. Well, again, we can't write 15 as 7 to a power. So what can we do? We can take log base 7 of both sides. And as we've seen and we know because of our properties, well, log base 7 of 7 to the 9x will simplify to 9x is equal to log base 7 of 15. So then we just need to plug in log base 7 of 15 and we have our answer, yes? So log base 7 of 15 is a non-repeating, non-terminating decimal, a really long decimal place, yes? Well, is x by itself? So wait, what do I need to do to get x by itself? We need to divide both sides by 9. So for us here, really, x is equal to log base 7 of 15 divided by 9. So we have to take that log base 7 of 15 and divide it by 9. Now you can type this whole thing in, especially with the graphing calculator, it'd not be too bad. Log base 7 of 15 divided by 9. Now on a non-graphing calculator, what I would do is do our log of 15 over log of 7 and get our answer. Not A and D. And then we can do A and S, or really if you hit the dividing key, after we find out what log of 7, or log of 15 over log of 7 is, and hit 9, it will also give you your answer, which is 5.5, third decimal place.
Wait. Yeah, 1.55. No. 0.155. Sorry.
So 3 5s.
Still 4.
Oh, 0.555.
It's 0.1.
Okay, 0.155. You're good. You're good. So 0.155. And that's it. That's all we have to do for this here. Any questions on any of this here so far? We good with everything so far? Some. What can we do first? Right, we're going to take log base 5 of both sides. Because as we know, log base 5 of 5 will simplify out, leaving us with just 3x plus 7 is equal to log base 5 of 311. Well, is x by itself? Well, no. So what do we need to do first? Yeah. We would need to subtract the 7. And after we subtract the 7, then we'll divide. And after we subtract the 7, then we can divide everything by 3, which would tell us that x is equal to log base 7 of 311 minus 7 divided by 3. Five. It is 5. Thank you. Yeah, because we started out with a base of 5, and for some reason, oh, I know why, because I was thinking of the 7. So it should be log base 5 of 311 minus 7 divided by 3. Because if we look back at the top, we did take log base 5 of both sides, and for some I would stay away from decimal form because I want to try to, well, this is just me. I try to keep it as precise as I possibly can. So I try to wait on rounding to the last possible moment. Now, so now I'm going to go on and type this up. Now using log base for this one here would not be too bad because we can do our fraction key log base and type everything in and it works out fine. Now if we weren't using log base, if you're wanting to type this in, especially into the yellow calculators, I would do it this way here. Because I would start out with log of 311 over, let's go down, log of 5 minus 7. And this was what essentially I used to change the base for the logarithm, minus 7. This is what we had in the numerator. Yes? I can hit enter. So negative 3.43366 going on. This is what the numerator is. But to finish it off, we divided it by 3. And I believe we get the same thing. So we want to keep it as that there because the less that we round, the better off that we are. Because it'll give us a more precise answer. Any questions on any of this here? So negative 1.145. Is our answer rounded to 3 decimal places? Any questions on any of this here so far? Let's look at one more of these because I feel like y'all are feeling comfortable with these type problems here. Yes. Let's look at this one.
You helped him with this.
Yes, I did. So what can we do first? We can take log base 36 of both sides. And our log base 36 of 36 will simplify and leave us with just 12x minus 5 is equal to log base 36 of 4,026, not 22, bless you. Yes. And then we would add 5 to both sides, and I'll scroll back down, which will tell us that 12x is equal to log base 36 of 4,026 plus 5. Then we would divide by 12. Log base 36 of 4,026 plus 5 divided by 12 is what we get. I might be off, but so there's at least, I know it's 0. I think it's a 10 at least.
.60,
0.60 or
yeah. You look at the answer.
okay. Yep, 0.6096 or 0.610 if we rounded to 3 decimal places. This is 0.60969. But this here would be our answer. Any questions on any of this here? So I feel, most of y'all feel comfortable with these here, with these exponentials. Now, we could have, I'm not going to work the whole thing out because it would work out the exact same. I could have used a smaller base because 36 is the same as 6 squared. So really this could have been written as 6 to the 24x minus 10, and we could have used base 6. And it would have actually gotten us the same thing. So it's another way that we can do it if we're dealing with perfect squares. Okay. Now this one here is a little bit different because now we don't have just one term on either side of the equation. We've got a few. So again, we're trying to solve for the value of x, yes? So we want to try to get it by itself. Well, there are some things with x. Well, there's the e and 0.30, -7 and the 4, yes? Now, what's going to be the easiest to get some of the stuff away from x? What would be the easiest thing to get rid of first? The -7, yes. -7 is going to be the easiest thing to move first because we can just add 7 to both sides. And when I add 7 to both sides, well, we have 4e to the -0.3 x is equal to 20. So the addition and subtraction was the easiest thing to move first. What's the next easiest thing to move? By? Dividing both sides by 4. Because that would leave us with e to the -0.3 x is equal to Then we're going to put L into both sides. Because once we get E by itself, we can take Ln of E to the negative 0.3x is equal to Ln of 5. It's just like with our logs, Ln of E simplifies to what? Well, it simplifies out. It becomes 1, yes? An easier way to kind of remember it, if we ln E, I make the L kind of look like a 0 or an O. It actually says 1. Simplifies to 1. Simplifies to 1, which just leaves us with our negative 0.3x is equal to ln of 5. Negative 0.3 divided by negative 0.3, which just tells us x is equal to ln of 5 over negative 0.3. Which, just like with the last one, all we've got to do is type this into the calculator. I believe we will get a negative number. Was that any harder than what we've been doing? No, we had to move some stuff over, get E by itself, then we could apply the natural log and solve. So wait a minute, we could have had problems like the ones we did before with this kind of setup. It's just adding, subtracting, multiplying or dividing, and then applying the logarithms. And that's it. That's all we have to do for these here. Any questions on any of these here? Three, e to the x minus 4 is equal to 8. We can add 4, yes. I feel like I think you said add 3. Divide by 3, yes. Which tells us e to the x is equal to 4. Yes. Then we would add the ln. So we get ln, because we'd have e to the x is equal to ln of 4. Really, we move the x out front, and ln of e simplifies to 1. X is equal to ln of 4. Is ln of 4 going to be a whole number? No. And that's it. Any questions on any of this here? What do we think of this here so far? We like this? I feel that y'all feel comfortable with this here with E as a base, yes? Because this one here actually is pretty much the same thing as what we started the lesson off with. Except instead of having a number as a base, we have E as a base. All right, now we're going to look at logarithms. Yes. So, if y'all had to guess at what we're going to do for this here, what would you guess? Well, we can't do that because we'd have to do it to both sides. And if we did it to both sides, we'd have log base 2 of log base 2 of 5x minus 17. And that'd make it a little bit tricky. But there was another way that we did simplify logs. There was a way that we simplified logs. Because when we simplified, if I had an exponent as a base, we used log base to simplify it out, yes? So if I have a logarithm and I want to simplify it out, I'm going to simplify it out with an exponent, using exponent, properties of exponents. So what could we do here? Put both sides to the base of 2. So that we get 2 to the log base 2 of 5x minus 17. Because according to our properties of logarithms, 2 to the log base 2 will simplify, leaving us with just 5x minus 17 is equal to 2 to the third. Now, we didn't simplify the logarithms because we ended up getting a really ugly decimal, yes? It'd keep going on and on and on. We didn't see any kind of repetition or way we can write it as a fraction. Can I write 2 to the third as a nice whole number? It is 8. Because if I know that I can simplify some of this to nice whole numbers, I'm going to simplify it to nice whole numbers. If I know I'm going to get an ugly decimal, I leave it till the end. Then we can add 17 to both sides, which would give us yes, then we would divide by 5. And then we would get 5 as the answer. Questions on this here? Now, the only thing I would check and make sure is when we look back at this here, 5 times 5 is 25 minus 17 is 8. We're good. We have a positive number. Because we just need to make sure that whatever's inside the logarithm is not negative. Because if I get a negative number inside the logarithm, that solution does not work. So let's look at this next one here. Log base 3 of 10x minus 9 is equal to 4. We would give both of them a base of 3, so we get 3 to the log base 3 of 10x minus 9. Well, on the other side, we have 3 to the 4th, which is, y'all know? You're good? 81. Because 3 squared is 9, yes? 9 times 9 is 81. Because 3 squared and 3 squared is the same as 3 to the 4th. So we can kind of break it up that way. Then we'd add 9. And that's our answer. And if we did plug it back in, we would see that this does work. Any questions on any of this here so far? Yep. So the 2 to the log base 2 of x minus 6 is equal to 2 to the 5th. So 2 to the log base 2 would simplify out, leaving us with x minus 6. Now we can simplify 2 to the 5th. Huh? 18? 32? Because 2 times 2 squared is 4, times 2 is 8, times 2 is 16, times 2 is 32. We can just keep multiplying our 2's. And then we can Any questions on this here? All right. Now, if we're applying a base, which this one here would be 10, because the base is not written, it is common logs, we really need one log on either side or just one log. We can't have two. And putting them on both sides actually wouldn't do us a whole lot of good, because then we would have the 2 and the log kind of connected together. They don't really work well. But if I have 2 logarithms being added, I feel like there's a property we had, didn't it? As if I have 2 logarithms with the same base being added together, I can rewrite it as a single log with what? What's inside being multiplied together. As this is using our properties of logarithms, that log base b of m times n is equal to log base b of m plus log base b of n. It's our multiplication property of logarithms. And this is kind of why it's helpful, because if I have 2 of them being added together, I can rewrite it as a single one, which is easier to work with, because now I can put both sides to the base of 10. And here, 10 to the log will simplify because the bases do match up. 10 squared is 100. So again, so yes, so 2x and our x minus 5, that's what we're going to need to deal with next. They are being multiplied, so we need to distribute the 2x. Well, 2x times x is going to be 2x squared. 2x times negative 5 would be negative 10x is equal to 100. So we have a quadratic. So that means we need to get everything on the same side. So we're going to minus 100 from both sides. And we minus 100 from both sides, we're going to get 2x squared minus 10x minus 100 is equal to 0. Is there a greatest common factor between all 3 terms, or all 2? Now, because it's just a number, we can divide the whole thing by 2. If the greatest common factor was a variable, we have to factor it out. We can't just divide it. Because if I divide by a variable, I'm removing a variable from the equation, yes? Which means I'm removing a solution from the equation. We can't remove a solution. What we're removing here is a scale factor. Essentially, all the numbers outside of where it crosses the x-axis, the values of x that make this function 0, would change, but those zeros do not. The zeros will not change. Now this here will leave us with x squared minus 5x minus 50 is equal to 0. And the reason we do this, especially with numbers, is, well, this here is a little bit easier to work with than 2x squared minus 10x minus 100. Now this is factorable. Well, we know that we're going to have x and x because x squared, only one set of factors. We would have plus and minus because the 50 is negative. And now we need to figure out which factors of 50 we want. 5 and 10, which one would be positive, which one would be negative? 10 would be negative and the 5 would be, because negative 10 plus 5 is negative 5. Any questions on this so far? Yes, sir. Because we divided the entire thing by 2. So if we'd have factored it out, then yes. But because it is just a scale factor, we can actually divide the whole thing out. We're not removing a 0 or a value of x. We're not removing a solution. So variables, we can't just divide everything by it. We have to actually factor it out and have it out front. But with a scale factor, we can. So when we look at this here, well, one of these must be 0. So for this one here, we would minus 5 from both sides, which tells us x is equal to negative 5. So these here are our two answers. Now we need to go back up to the top and check to make sure that these work. Negative 5 would not work. I'm going to erase this here so I have a little bit of room. Because if we plug negative 5 in, what we get is log of 2 times negative 5. And I'm going to put that in parentheses. Plus log of negative 5 minus 5 equals 2. Well, here I'm going to have log of negative 10 plus, well, we're done already because I have a negative inside one of the logs. And we always want to check it with the original problem, not any of the ones that we actually manipulated it. So log of negative 5, or x is equal to negative 5, does not work. And if we check log of when x is 10, this will work, because we'll get log of 20 plus log of 5 is equal to 2. And if we plug that into a calculator, it will tell us that this is equal to 2. Turn it on. And if we type it in, we will get 2. So our answer for this here is actually x is equal to 10. The other value of x that we found was considered an extraneous solution and cannot be included in our answer choice. Any questions on this here? And that's all we're going to do for today.